Hello friends, this is Akash. Welcome to CloudML. This is the second video for the Hackerearth Deep Learning Challenge where we will identify the dance form. So we will start from the coding part. So here we are using the TensorFlow Keras library and importing the image generator. So image generator will dynamically generate the image for us from the directory we have already mentioned in our previous videos. So these are our two directories. It will fetch the image from these two directories and feed to our algorithm for learning purpose. So we are using TensorFlow STF. So this is train image generator. We are rescaling the image for the purpose of faster running, because scaling is something important in machine learning to make the algorithms run faster. It won't affect our performance, it's just that it will increase the speed of our learning. And this is a validation data set. An image size I have kept as 50, so wherever I am using like it's 50 by 50 pixel, you can say. So train data, it's dot flow from directory, means the image will be flowing from this particular directory, train directory, and train size is here, and the class mode is sparse. Sparse we will use when we have multiple classes. If we have two classes, then we will use binary. So here we are seeing so many folders are there. Similarly, all the folders will be labeled as different category. So we have 8 folders, so we will have 8 labels, with the labels being this folder names, and the validation directly is generated similarly. Then we are going to build our neural network. So this is our Keras sequential neural network. So we will start from convolution layers. So diving deeper into convolution layer is out of the scope of this video, but I will give you a brief understanding of what it is. So I have come to this web page. I will give the link in description. Basically, this is a computer graphics operations which we are doing. So we will have filters. These are like filters. So if you can see, I have used a 3x3 filters here, and they suggest to use uneven 3x3, 5x5 or 7x7. So they are using this kind of filters. They have written this code, and you can see the effect. So this is original image, and using this filter they have blurred it out. You can see the image has been blurred. So this kind of operation they are performing on the images to make more sense out of it, more sense in the sense of edges. See, if we are able to identify the edges, suppose we are identifying face, eyebrows. If we see eyebrow is there in some image, so most probably this is a human face. So similarly, they have filters to identify the edges. Yeah, so here they are trying to identify the horizontal edges. Yeah, so this filter is 5x5. Using this filter, they are identifying the horizontal edges. In the next filter, they are trying to identify the vertical edges, and you can see the edges, vertical edges are being highlighted. So similarly, there are many operations, and some operation like sharpen the image, which we are performing to identify different features of the image. So it is very useful in image analytics, just by not considering the pixels, but also considering the features of the image, highlighted features of the image. Next, we are doing max pooling. Max pooling is nothing but it is just reducing the size of the image. 2x2 means it will just half the size of image. And so here in convolution we are given 16 types of filters. So it is automatically, TensorFlow at the backend will apply different kind of filters to check which is fitting the best. So next I am generating 32 filters, next 64 filters. In between I am reducing the size of image. After that I am flattening all the data, because if you have seen the structure of neural network, if you have not done, please have some brief idea what a neural network looks like. So we will flatter all the inputs in a single length array, and in between I am putting 512 dense layers with ReLU activation. Similarly, I am putting dropouts for regularization to avoid the model overfitting. Then normalization, I am normalizing the data. Again, I have a 512 dense layer in between. At the end, I have something called softmax. So the purpose of this softmax is to classify phi. So if you see here also we have a softmax, we have around 5 classes. It is telling which class it belongs to. Only one class can be yes one time and others will be no, meaning only one among them can be 1 and others will be 0. This is how the softmax helps in classification. So I was mentioning about the neural network. So this is a basic neural network where the inputs are in flat form, like one dimension array, where all the things, like here what the flatting part was done, right? All the bytes were flattened in one array and it was fed in the neural network like this. This is not dense layer. Will come above. Here we can see we have hidden dense layer. These are those layers, this layer and this layer. These are those hidden layers which are called dense layer. If we don't have much hidden layer, it's called shallow, otherwise it's called deep neural network. That's why we are doing here deep learning. So moving forward, we will compile our model. So here what we are doing, we are telling that please compile this model and make the loss function as sparse categorical cross entropy, meaning this is our categorical problem. 8 classes are there, so try to reduce the classification losses. That's what we are telling to this function. An optimizer is Adam optimizer. I'm not going to dive deep into this, and the metric we will use is accuracy metric here, just for visualizing how well the model is performing. Next, going forward, we are going to fit the model. So we will do the train generator. Okay, for we are going to fit on this, and epochs will be 15, means 15 times we are telling this neural network to iterate over itself and improve the learning to reduce the loss every time on each iteration. Verbose is just to mention what's the things going on in each iteration is 1, so I want only basic description. And validation data to just to see how our data is performing on the unseen data, because we are training on this data and this is a different set of data which the model has not seen. It will just make a prediction and see how well it is performing. So we are going to run all of this. Yeah, so the training has started. So the training got completed and we got an accuracy of around 99% on the training set and the accuracy of 44% of the validation set. So that's it for now. In the next video I will show how to make prediction on the test data given by Hackerearth. So here we have the test data, and based on this data only we are going to make the predictions and we will upload it in the Hackerearth website and see how our results are performing. So all the link of the website I have visited and shown you will be given in the descriptions, and the code link will be given in the description. Please, if you have found this video useful, then please hit the like button, share with your friends, and very importantly subscribe to the channel. It helps me a lot, encourages me to make more such videos. Thank you very much.